Hello, my dear students. Once again, welcome back for the continuation of chapter 6, that is electrolysis in chemistry, electroplating, electrorefining, and electrometallurgy. These are the applications of electrolysis. In previous class, we have done electroplating an article with silver or nickel. Today, I would like to explain you electrorefining of copper. Electrometallurgy will do in metallurgy chapter. So before I start, I would like to explain you what is electrorefining or purification of metals. The refining of impure metal to obtain a pure metal by the process of electrolysis is known as electrorefining. Now we are electrorefining of copper. Here thin strip of pure copper is made as the cathode. Cathode is the electrode which is connected to the negative terminal of the battery. Here anode. Anode is made up of a block of impure copper which is connected to the positive terminal of the battery. Here aqueous solution of copper sulfate is used as an electrolyte. Here electrolytic reaction. Copper sulfate dissociates into copper ions and sulfate ions. Water molecule ionizes into hydrogen ion and hydroxyl ions. So this aqueous solution of copper sulfate contains copper ions, sulfate ions, hydrogen ion and hydroxyl ions. When switch is on, electric current enters into this electrolytic cell. Now what happens when electric current enters into this electrolytic cell? All positive ions, they migrate towards the cathode. All negative ions, they migrate towards the anode. Here we have two positive ions, copper ions and hydrogen ion. Both of them, they migrate towards the cathode. Only one of them, they discharge at the cathode, that is copper ions. Because the position of copper ions is lower than the position of hydrogen ion in the electrochemical series. Therefore, reaction at cathode, copper ions get reduced or get discharged or become neutral at the cathode by the gain of electrons and form neutral copper atom, and this copper atom gets deposited at the cathode. There are two negative ions, sulfate ions and hydroxyl ions. Both of them, they migrate towards the anode. None of them, they discharge at the anode due to the nature of the anode. Anode is made up of a block of impure copper, which is an active electrode. Rather, this copper atom loses electrons and form copper ions. Therefore, reaction at anode, copper loses electrons and form copper ions, and these copper ions are added into the solution. Now here anode is made of a block of impure copper. Whatever the impurities are present there in the anode, these impurities get deposited at the bottom of the anode, which is known as anode mode. Now here, what are the spectator ions? Sulfate ions, hydroxyl ions and hydrogen ions. These are the spectator ions. Now what are the spectator ions? Spectator ions are those ions that they do not take part during the electrolytic reaction. Now what do we observe during this process? The size of the cathode increases because all the copper ions get discharged or reduced or become neutral at the cathode and get deposited at the cathode. Now, what will you observe at the anode? The size of the anode decreases because anode consumed during this process. Now, blue color of the solution remains same because the copper ions which are added into the cathode from the solution, this copper ions added into the solution by the anode. On the basis of electrorefining of copper, questions may come in ICSE like name the electrolyte. Electrolyte is aqueous solution of copper sulfate. Name the cathode. Cathode is thin strip of pure copper. Name the anode. Block of impure copper. What are spectator ions? Spectator ions are those ions that they do not take part during the electrolytic reaction. Name the spectator ions here. Sulfate ions, hydroxyl ions and hydrogen ions. These are the spectator ions. What will you observe at the cathode? The size of the cathode increases. What will you observe at the anode? The size of the anode decreases. What is anode mode? Impurities which get deposited at the bottom of the anode is called anode mode. So dear students, here we come to the end of this chapter. Please go through this video clip. This will help you all.